All right. The ABCs of IFC, as Damon aptly named it, because he gets exhausted at me spewing acronyms. So he wanted to know a little bit more about the depths of some of it. One thing I learned in college, one of the first things I learned, and probably one of the most valuable things I learned, is the fact that I wasn't going to learn everything that I needed to know, but I was going to learn where to find it. So that's kind of what I'm hoping that this is going to do today, just a short overview of concepts, and then we can discuss further. I want this to be interactive, so as we're going along, just shout out when you have a question or want to know something about it. But figure out where to find the information that you need, and also give you an overview of what's going on with this thing called IFC that I'm constantly spewing, I suppose. IFC, I've used the term in some other presentations. It's the HTML of the building industry, and with you folks in here, you're probably all familiar with what HTML is. It doesn't matter if you have an iPhone or a Windows phone or Android phone, it doesn't matter, or your laptop or your desktop or any other kind of interactive device. And it doesn't matter what it was written in. It could be written in iOS, it could be written in C#, it could be written in Ruby on Rails, it could be written in any language. But the bottom line is, when it's viewed on our screen, on that screen, on this screen, it's HTML. So HTML is ubiquitous in terms of devices being able to leverage that language to display all this information that we use. So I try to equate IFC to the same thing. It's a way of storing all data relative to building models, to a physical structure, a facility. We'll start back in one of our challenges. This is a compelling perspective, and maybe some of you have seen this, but this was a study done by Paul Teichholz. Paul was, I believe he was at Stanford when he did this. But anyway, it was a 40-year, originally 40 years, and he just updated it in 2012. He did this in 2004. But it's a line, it's a graph that shows us essentially the comparison of construction labor productivity compared to every other productivity measure within our gross domestic product here in the United States. And construction productivity in that first 40 years declined almost 20%, where everything else rose almost 200%. So this is all other non-construction industries, and as of 2012, it's almost 250% since 1964 increase in productivity. And the belief is that much of this is attributable to technology adoption and utilization of technology within the processes. So in the construction industry, we have started using technology, but there's not most of those that are from an office of a construction manager. This diagram looks quite familiar. Things start out in design, and they might be using a CAD station to design a building, because it came from the tracing paper and went into the design, and then out of that CAD file, if you will, permits got procured. The owner and everybody submits for revisions and RFPs. Fixtures got ordered. Landscape got designed. All these other sub levels got flushed out, for lack of a better term, in terms of definition of what is going to be done. How's it going to be built? The HVAC system, it just had maybe a reflected ceiling plan in the original design documents that showed roughly where they went for aesthetic purposes, but the size of the trunks, the size, all had to be defined later on. And that ends up in that pile that we see down the bottom on the site that all the contractors are using of all this paper. Now, technology, all it's really done is taken a lot of this paper and made it a PDF, and now we're emailing these same data, if you will, these same products around. Creates a lot of confusion. On comes IFC, and I should have started out. IFC stands for Industry Foundation Classes. I can get more into the technical stuff. I don't want to dive too deep into the technical stuff. We can offline afterwards or in the questions. I just want to kind of keep this as a high level of what the purpose is and what we're trying to accomplish with the IFC. It's meant to be a data, I call it a data ball. And the reason I call it a data ball is to not confuse a lot of people with the term database. They automatically think of rows and columns. That's not what IFC is about. I call it a data ball because IFC can live beyond our current database structures, and even into some of the large data that you've heard about, big data these days, blob storage, and other types of data storage that is not necessarily in a structured table, column, row environment. Yeah, that's great and handy, and we're all used to using spreadsheets, but there's a lot of better ways in some cases of storing the data. So that's why I use the term data ball, and it serves this whole building life cycle. So back to the diagram a minute ago from the gentleman or lady designing the building in what we have known as CAD, all that's really accomplished was it's saved us erasers. In other words, we're creating, for many years, many people, many businesses saw that as just a way to electronically place lines on paper to represent the building. Now we're getting more 3D and more involved, but from those early building concepts and the three dimensions that we're dealing with and solving more problems, it goes all the way through the product execution, because a lot of times, what has happened to date is those drawings, if you will, were the representation of what got used to get the building constructed, and then those actual drawings got marked up as as-builts. Anybody here that's ever worked in the field knows that the as-builts get done to get your retainage released, and it's 4 months after. How far did we move that wall over in room 109 because that column was, that's usually how as-builts get documented. And then they all get rolled up and put in the basement on a pallet somewhere when the building gets commissioned, and then they don't really get used often, because what happens is nobody can rely on the data that's there. They don't know how it's changed or if it's changed, even during construction, or 5 years later through somebody calling because the heating went out and some HVAC contractor came in and replaced an air handler unit, and there was no documentation of that. So through the whole building life cycle, we want to maintain the exact same data store all the way through each of those steps. And then not only that, the full building life cycle goes into, this is a great example here, this building, or any other office building. They go through every 5 years or so almost a complete shift and renovation. I mean, life safety and many of those things, a lot of times through tenant finishes, has to be resubmitted for permits and so forth. So that data, again, that data ball can be used to generate the request for a new building permit, and used to do the design for the new tenant. And you're working within the shell and the confines of an existing data store that already has all of the pieces in place. Right now, many design firms that get hired to redo a facility, they'll spend an incredible amount of money, budget, resources, going in, and anywhere from a day for a few hundred square feet to weeks on an existing structure, just trying to document what's there geometrically, if nothing else, not to mention all of the systems that may or may not ever get redocumented and consequently utilized. The other place that with the full building life cycle, it goes into even deconstruction and deactivation. So that building no longer serves any purpose or use on that piece of property. It's going to be deconstructed, and by using that same data store, it can be deconstructed, and people will know what materials are within that building, and it won't be such a mystery. And how old those air handlers are, and can they get reused in the new facility going on or somewhere else, and have all the history. And not to mention, we're all the way down to the infrastructure. Now, just last year, the body Building Smart International, who has developed most of the IFC, also expanded IFC not to include just the physical building, but also infrastructure, utilizing standards as standard. Building Information Model, that's what BIM stands for. It's much maligned. It's been used as a marketing term. But there is one definition that we have on record from a body, from the Building Smart Alliance. It's a digital representation of the physical, here's the key, and functional characteristics of a facility. So not only does that data store represent this wall with those windows, it knows the U value of the windows, the STC values of the materials in this wall assembly, that, the standard transmission coefficients, and all these, the weights for a structural analysis. And those parameters are really the important parts of this data store, more so than just the geometry, the drawings, the representation. So that also there can be numerous studies take place on the utilization of that facility, especially with sensors coming in now. It can interact with the IFC data store to tell us what rooms are occupied when and what percentage of the time. And oh, hey, maybe we can use this room for X, Y, or Z functionality on these times because it's never being utilized. Just any number of things that you could imagine are that capability will exist within a data store that's like this. BIM is, so I kind of said what it is in a little bit. It's not just lines, but it's all these things. And in all honesty, right now IFC is an ISO standard developed by Building Smart International and utilized by 17 other countries. The rest of the world is really ahead of us a little bit in terms of the United States in mandating utilization of it for the purposes of a complete data store for the facilities. The UK government in 2012 passed a mandate that by, I believe it was 2016, any facility that is paid for with government funds will need to be in compliance with a database compliant with IFC and the ISO 16739 standard. So one new little tidbit that I didn't really include in here, but I think it's kind of important: permitting. To be able to use the same data, if you will, that's created by an architectural design firm. Right now, it's a very arduous process, as you can ask anyone, any building owner, any architect, getting through life safety permits and all of the permitting processes for approvals for a building. It's an arduous process, and there's an organization here at University of Texas Austin called FIATEC, and they're somewhat of a consortium. But anyway, they're spearheading the Smart Codes project, and the key is that Smart Codes project, which was originally part of the ICC, which is the International Code Council for Building Codes. Well, they completed the project. They showed us about a year and a half ago at the National Institute of Building Sciences conference, and the title of their talk went from 60 days to 60 seconds. They were able to work with 6 different municipalities on commercial structures and able to submit an IFC file and have approval within 60 seconds, or disapproval, and why? Because it was able to do all the code compliance checks through the data. So things like this we're seeing, where it's not just in the design phase, it's flowing all the way through back to the building life cycle, but there's certainly in the design and execution or construction phases, there's huge opportunities in using a common data store. This is a Steve-ism here. There'll be an app for that and that and that, and this is the way I see it coming, is that we'll have many more small applications specific to the needs of a given stakeholder whether it be an electrical contractor, a building owner, a building maintenance supervisor, a tenant on building automation. All these apps will be able or will be accessing the same data store of an IFC data store and getting the same information and not have to be imported, exported, translated, so on and so forth. Back to, not to say that these apps can be black box proprietary code, but the key with IFC is it's an open data standard, an international ISO open data standard, so that structurally anybody can design an app to interact with it.
So who stores the IFC database?
Right now, there's a number of utilities, if you will. There's an open source one called BIM Server. Actually, they've used it at some of our other hackathons. Right now, we're seeing it's Genesis. It starts with the architect. That's still being developed to some degree. I mean, that's why we're trying to bring some of this to these hackathons. I think we're going to see services that'll provide cloud storage that will be a place, you know, Autodesk has done it some with their 360, but it's just their product. But I think we're going to see, if you will, rented storage closets for these data stores. And then eventually they're going to be owned by the building owner. I think what we're seeing coming, and I can talk about that a little bit, but I'm going to show you where to go get all this information. There's a thing called a MVD, or a model view definition, because we're talking about a data store of everything possible to know about this particular building. But not everybody needs all that information. So how do we access it? Well, these model view definitions can be written for specific disciplines. Malcolm and I were talking earlier, and Damon, about life safety, the fire department. Well, they maybe only need to know, I mean, they do only need to know certain things about, you know, exit and entrance procedures and so forth to buildings. So there would be an MVD for that utilization. And even those are standard throughout the world. And they're able to be set up by them. But so anyway, to answer your question, it's still being developed. I'm sure some of them will be housed in their own servers. They can be. But I think we're going to see services come where when a building owner builds a building like this, part of that whole building is one of the utility bills you're going to pay is the data store of the building model. So anyway, you know, but there'll be many apps for that. One analogy that I use for in residential, because I talk about this in residential some, is that you and your other half are at a movie and your smartphone vibrates and oh darn, my AC unit just went out. Well, and then you can give you a choice. Do you want to call this guy or this guy? And all you have to do is hit the button, and what's sent to him out of the data model is what the error condition was, you know, the fan through a fan belt, and here's the part number, and oh by the way, here's a four-digit access code to the front door, one time used to get into the house, and then he bills it online. So the AC unit's actually taken care of before they get home from the movie. Take that into even a facility like this and start using some of the things that we mess with the hackathons. Walk into this room, if this had all the ceiling tile in, the HVAC guy wouldn't have any clue where the air handler was above what tile and what ceiling. Well, you know, with having that data store, it has the capabilities of leading him to that tile and showing him to move that one. And oh, by the way, you need this, you know, a 10 millimeter nut driver to open the access panel. And you take out these 4 screws first, and anyway, it can really delve into farther. So that's where the apps. So instead of because a lot of people think we're trying to boil the ocean here with IFC, it's not. That is, again, it's just a data store that's being accessed by 1,000 different flavors, kinds, or conditions of apps. This is just one example, and I'm not here to promote it, but it's I know the guy well. He's developed as a little tool, but this is being used heavily in the rest of the world. And I'm not saying we need to develop or use it, but this is the type of thing that I think is coming. And it's just a 1-minute video that
Constructivity 1 is a single software application that brings
This is an
everything together in
IFC
one
file
place
that
for
he's
building,
working on.
design, and construction. What typically takes dozens of separate applications that don't work together, Constructivity covers it all. Architecture, structural design, HVAC, electrical, plumbing, scheduling, estimating, construction management, facilities management, building automation. Constructivity not just does it all, it integrates it all in one place. Change a wall, immediately see the impact of structural, energy usage, cost, schedule, and more. And you don't have to be an architect to use the product. Everything can be directly edited in 3D in real time. With an intuitive yet powerful user interface, Constructivity is easy to learn and quick to master. With Constructivity, you don't just see a 3D image, you see every engineered part, who builds it, when it is built, where it comes from, how it is constructed, and why things are done the way they are. Constructivity Server enables teams to collaborate, where employees, subcontractors, and other team members can create, update, and view projects, where changes are automatically merged and conflicts intelligently resolved. Constructivity puts you in control of your data. It is the first and only software application that can edit 100% of industry foundation classes, the global standard supported by over 150 software applications. Constructivity is also the fastest and most scalable building information modeling platform on the market supporting IFC, blowing away the market leader by an order of magnitude. So loading in buildings takes seconds instead of minutes, and you can access an entire building at once, not just a floor or a discipline. Constructivity 1 is available now.
And I seriously don't mean that to be an infomercial. I only did it to give you a flavor of that particular tool. Many people don't use it to initiate it, but they will use it to pick up an existing IFC file that was maybe made with some other system, and maybe they're just working on the electrical systems. Maybe they're just working on the building automation. They could be working on any different piece of it. That's the way that software tool is being used all over the world today in 600 or so different installations. Just a little bitty company, little bitty, lightweight. You could download it in a pretty short time. I think the price of it is $700 or something. I mean, it's but anyway. The key is that I think we're going to see a whole host of those coming along. One of the things that, interoperability, that's what all this text really comes down to. It's open and neutral, and it's based on ISO specification, but that concept of multiple apps that are in all different domains and codes and languages, being able to interact with a single data store is interoperability. Having that interoperability between all these, yet using the same data. We don't have to worry about it being disconnected. Oh, this got updated over here, but it hasn't updated over there yet, what the guys are using in the field. Everybody should be working off the same data store. Recently, there's it's called another alphabet soup, BCF, BIM collaboration format. It's another open standard by the Building Smart Alliance, and I'll give you links to where you can find out all this stuff. But it actually ends up being a traffic cop, if you will, to the information flow. You set up rights of who can change what in that data model. You know, obviously, if the HVAC mechanical engineer is in trying to get his ductwork laid out, and there's a structural beam that is in the way, and I mean, he can't do anything anywhere else, that's class. It's going to come up in a class detection. It's going to be a problem. Well, with the VCF, what would happen is the structural engineer would get notified, and those two guys would begin to work on because they're all working off the same model. It's not like one's disconnected from the other. That with having a communication platform like that, yeah, the HVAC guy can't get rid of that beam. He can't cut out that beam, but he can notify and begin to collaborate with the structural engineer to get that resolved. Another thing IFC does is, and this has just blown me away, you know, even in cost codes and so forth, this is what got me into this years ago. I implemented a lot of systems for the construction industry, and one of the most ubiquitous products that we use in building, either whether it's homes or commercial buildings, is a 2x4 pre-cut stud. Nobody has a product code for that, but yet we have folks in here. I know, Sunil, you live here in Dallas, and if you go to a grocery store, I don't care what brand it is of a grocery store, and you go into the self-checkout and you have bananas and they're organic, you're going to punch in the same thing I'm going to punch in Ann Arbor, Michigan, 94011. That is a product code, but it's not adding any value for every construction company, every building owner, everyone else to have their own product codes for all these things that they're managing. So IFC is another way while it may or may not have a specific, and it can have specific product codes, having these properties available keeps it from having to be translated or having libraries and so forth for it. This is another, and I don't usually like putting videos in the presentations, but this does such a great job. It's a new video that Building Smart, who is the godfather in the world of IFC and a lot of what's going on, it does a great job in a pretty short period of time. It's a 4-minute video, so
what Open
probably better
BIM
than me.
does for you. Why the AEC industry needs to change. The building industry has experienced negative growth in productivity.
Same
in the
chart I
last
used
decade.
earlier with Paul's.
The building industry is divided into many specialized disciplines. In order to design, construct, and operate a building, all disciplines have to work efficiently together with the same information. In conventional processes, information is exchanged on paper. This makes room for many different interpretations, mistakes, and errors. In all conventional projects, expensive errors are made due to lack of coordinated information. Often, time schedule and budget are exceeded. How does it change? By sharing all information between all actors in one open format, everyone can work efficiently without errors. A building information model, or BIM, is a digital representation of the real building. Each object in the real building is represented by equivalent digital objects in the BIM. All building information is shared by one open format called IFC and a standardized terminology called data dictionary. All project actors can access relevant information when they need it so that everyone can work efficiently together. How do we want to work? Let us give you an example on how we want to work with the building information models.
We want the school!
The client document their requirements in a database that follows the project the entire life cycle. The design team designs the building according to the client's requirements. The building is modeled by numerous digital objects. One of the objects is a door. The door is chosen from an object library in the design software. The design software automatically adds information about the position of the door. The consultants add information and requirements for dimensions, material, color, fittings and surface, thermal transmittance value. The architect positions the BIM in a digital map to enable the contractor to know exactly where to build the school. The project team uses the BIM to coordinate the disciplines and to analyze project cost, analyze life cycle costs, analyze energy performance, and other environmental impact factors for environmental certification. The BIM is sent to the local building authorities to get a building permit. The authority's BIM server automatically checks the building and approves the project. The contractor uses the BIM to plan construction, to communicate with building product vendors to get quotes and environmental information on all the building components, including the door, make their own cost estimation. The contractor accepts the best offer from the product vendors. Automatically, all product information is added to the BIM, while the real door is transported to the building site.
Hooray!
The property caretaker identifies the door with his handheld device and registers the damage. All the door information is available at hand, and he can order new parts on site. The glazier repairs the door. The event and all information about the new parts are registered in the BIM. Building Smart is the solution. Building Smart's IFC format exchanges geometry and object information. IFC exchanges the building model. Building Smart Data Dictionary standardizes all types of entities, properties, and classification. The data dictionary ensures that all software understands the information in the building model. This is how we make the building industry work more efficient and produce more resource-efficient solutions. We need to document and share all information by one open format using one standardized terminology. That is building smart in the industry.
The Norwegians, a number of my friends are there, and actually they worked with me they actually have a BIM manual to start utilizing some of the current technologies of, how can we use AutoCAD if a vendor is doing that to emulate some of these concepts and so forth. And it's part of it. And a year and a half ago, we did get the National Association of Home Builders, which is a fairly large entity, to actually recognize our current national BIM standard, which includes IFC. And my purpose for getting that resolution through NAHB was so we could start to get some of the building product manufacturers, instead of having the building product manufacturers having to create a DWG format for their chair or their window, and a Revit file format, and a SketchUp file format, and all these native file formats, to at some point we'll get to where they can all create just a single data file of their objects in IFC that any of those could consume. Lot to be for it. So these are a few of the links of Building Smart. Is if you go to buildingsmart.org, you'll get you can get to all the rest of these. They did touch base with the data dictionary. One thing that I can relate to you how powerful the data dictionary concept is in Norway. A door may or may not be, like here, a door can be just a leaf, just what opens and closes. In Norway, I believe, I might have this backwards. In Norway, if you're speaking in terms of a door, that includes the hinges, the frame, the handle, the lock, everything. And so the data dictionary handles these kinds of things. They even had a demonstration at one of our Building Smart symposiums about 3 years ago. It was held in China, and the Chinese are back big involved in Building Smart again. But anyway, where they had some people from, I believe it was Thailand, and another group from one of the Norwegian, I don't know, Denmark, whatever, opened up the exact same IFC file, but it did, through the data dictionary, they each could read it in their native language. Not just language, but even nomenclatures, ontologies, lexicons, all that can be managed through the Building Smart Data Dictionary as well. So, we're in a global industry. A lot of people, I think, in our industry don't understand that, but there's not a building product manufacturer in existence here. Kohler, Siemens, any of those guys that aren't in business globally. So the more that they can see that they have these global standards, the more they're going to be looking to use them. I'm going to close it up with a little ditty that talks about IFC, that this guy turned it into a song.
Well, I used to draw with 2D lines. I used to say these WG5. Some were lucky to open these, others stuck with blocks and fills. IFC is open and it's free. IFC, try it and you'll see. Yeah. Beams and slabs and walls and doors, 3D forms and even more. Have details with Chinese text. I used to send them in a PDF. Arrows and labels and custom fills, but my zone stamps are lost in the hills. IFC is open and it's free. IFC, try it and you'll see. Ducts and tubes and pipes and floors, collision detection and even more.
this whole thing, you know, it was meant just to pique your interest, hopefully, in what the capabilities are in a common data store. I'm in no way intended for you to be able to walk away from this with an intimate knowledge of how to utilize it. So, get with me, you know, if you want, I can steer you in the direction of finding more information and specifics and people that are using things. I'm happy to do that. Hopefully it'll spawn some discussion on how that can be utilized going forward, and hopefully you can see the value in the concept of a data store through the whole building life cycle. If nothing else, it'll limit what I call brain damage in our industry. And that is when we all kind of run around going crazy looking for some information that somebody says got changed, but nobody knows for sure if it did. Questions, comments, curses, criticisms, whatever?
So, in the engineering field, there's the step file. And the step file is supposed to be this wonderful everything, you should find it here, and it's so not. Because every little software package, you know, either wants you to pay extra for the ability to use step files, or they export a weird one, or it gets re-imported weirdly. Like, how is IFC trying to deal with that?
IFC is a step file.
Okay.
IFC, to be technical, is written in and step files in the express step format. That is an ISO standard in and of itself. I think it's 1303, 13003 or something. So it uses that format for IFC, but where IFC rises, that's just the structure, if you will. What IFC is really about the property sets, and the property sets are what can give you how much that glass in that weighs. I understand exactly what you're talking about, and I think part of the problem is because a discussion I had yesterday with some folks here is we're still polluting our data with imports and exports instead of having integrated applications that are reading and writing these files directly. That's where so much, and then you get some vendors, some software vendors that want to make theirs proprietary, and even though it's coming across as property sets, it might have some text that's not part of the IFC standard describing some of those, so then it doesn't fit in with any of the rest of the data store.
Yep. And the data gets lost.
Right.
Because that data is
It's
lost,
missing pieces, and you don't know what you're missing.
Yeah.
So that's why I am waving the IFC flag and promoting integration, not an interface. The interface is the bane. It's to me, an interface is no different than an open wound on your arm. It's open for infection. You know, you're not going to get an infection in your arm unless you've got a cut. But once you got a cut, then you got the potential of something getting there and infecting it. So to me, that an import and an export is a cut. I hope I answered your question. And we're not there yet.
Yeah.
I mean, we're globally, we're not there, certainly nationally. Now, the rest of the world is way ahead of us. I had a software vendor that I spoke with at the International Builder Show a few years ago, and everybody at this is saying, BIM, we're BIM, we're BIM, we're BIM, all these CAD packages. And I'm saying, oh, tell me about your BIM. And he says, oh, well, you can export the whole list of building material, all the studs and all the electrical and all. I said, oh, okay, great. Have you ever thought about IFC? And he laughed. The guy laughed at me. He said, oh, that's 20 years out there. Those people are still have no idea what they're doing with that, and it's never going to happen, and blah, blah, blah. And I said, well, all I've heard you say about your BIM is BOM. I said, we did that in 1991 with AutoCAD. You know, we were extracting schedules of doors and lumber quantities and all that, you know. So anyway, he was a Canadian CAD vendor who had actually, anyway, he was a Canadian company, and that was in January. In May, I get a panic phone call, Steve, and I only met the guy at this builder show. He goes, where'd you say I can find out more about this IFC thing? We're trying to open up a reseller store to sell our software in Singapore, and the government won't allow us to sell our software unless it's IFC compliant. So anyway, we're getting there. And the smaller governments are mandating it. We don't really have that capability here. You know, with the UK, they've mandated it, and a lot of people are scrambling to get some more of that going. So you're seeing a lot of these, that's what I call their Band-Aids or duct tape or interim solutions.
Yep.
And that's the price we're gonna pay for it, but I think it's part of the iteration of getting to utopia, so to speak.
Well, and once we get there, we'll discover what all is wrong with it.
Yeah, absolutely.
That I completely agree with this idea of IFC and then this video and what you said what open beam does for you, this thing. And that's exactly what, for instance, like that company I work for is trying to aim at. But I think the focus at this point, we had a little bit discussion yesterday, is that the IFC is only one part of what we want to do. And data is definitely a central part. But at the same time, like we talk about this cloud and the new type of data, for instance, like Macon just explained about this, the scanned data. And he at one point mentioned that, oh, maybe we can just skip the data at all. And that would be actually ideal, right? Nobody wants to construct data of existing models. And we just don't know how seamlessly we can switch back and forth with those existing data versus, this CAD data. So there are a lot of unsolved, we still can't have any single answers, but I think it looks like everybody is looking at the same direction, the future directions, and we try to fill the gap, connect the gap, and I kind of feel that.
I agree with you, and I think, in all honesty, it'd be great if there was something that was more cohesive and even simpler than IFC. Maybe IFC is not the answer, but today it's the only thing we have that is a global ISO standard that the masses are pointing to. So by virtue of the fact of everybody having the same set of problems, until something else comes along that can become the real standard, I think we'll see adoption.
Needs will always change.
Which adoption will actually evolve the whole data store to something more effective.
And then so he was talking about where we store the data. And also yesterday I mentioned that I work for building sites.
Mm-hmm.
And the idea is exactly the same. We have multiple people from all the building cycles. We want to share this data. And then in that respect, it's not limited to the data format, but where data belongs, and who is managing, and who is responsible for keeping the data for 75, 100 years. So in that respect, this cloud is getting a lot of attention because, like Amazon, for instance, they are doing a beautiful job of storing whole data and searchable data. And so those are the ones we are kind of focusing in. BIM is not trying to break IFC ideas in terms of common data. And in fact, you can use like the Sia was just demonstrating this the viewer side, and you can actually take a IFC model and then view it too.
Right.
And end user, for instance, like facility management, they may not really care about which data format as long as they can get what they want.
No, you're right. But today, one thing that has to happen for facilities management is a great example to see where there are benefits here. Right now, the way it actually happens is a building is completed and goes through commissioning. A facilities management company comes in and typically spends and invests an incredible amount of money going through that building and documenting every air handler, every light bulb, the life, the maintenance, the maintenance cycles, that's really unnecessary because that should be just exhaust from the design and execution construction process. If the data there was ways that it was standardly collected and made.
Yeah, that's exactly some of our customers doing. Now, being, for instance, we use like an Xbox kind of thing, and now we are kind of putting
Uh-huh.
building owner and big construction company, they actually doesn't stay there, just stop there. They want to keep all the data
Yes.
for keeping like 97% of this building
Yeah,
cycle.
you're exactly right, Mika. You make a great point, that the expense to a building owner, especially of a commercial building, and really of residential, it's just that not many studies have been done. 97% of that cost is after the construction's complete in the building life cycle. And to be able to manage that effectively is a whole lot of value that can be added.
Was it from you? I think that, I thought it was your presentation, was it your presentation? 97%.
Yeah, I think my number was 93 something or something, but
Yeah,
it's close,
93.
close enough.
Yeah, it's in the 90s, let's put it that way. It's a significant, it's a significant portion of the dollars that are expended.
Yeah, I just thinking, where did I see this?
A lot of, it's a lot of money.
Somewhere, yeah.
So, and it doesn't really benefit anybody except the proprietary data holder of having those separate silos of data information. And I think, you know, in our world, becoming a more shared and collaborative environment through technology, that's just almost like a natural iteration, I think. But it is going to be an evolution. It's not something that we can just, that somebody's just tomorrow going to have the answer to. It's going to take a communities like ours to help champion some of this and come up with ways to effectively manage it better. I think we're going to also see a wholesale industry open up to house that data store as a service for building owners, because also I think we're going to see the governments get involved once the municipalities realize that out of that IFC data store, they can get all the life safety information. You know, Damon, we were working on something earlier to dispatch the fire department out, you know, based on an annunciator panel. Well, it can give them exactly what they need to do to go through that building before they ever get there on their smartphone. You know, that kind of data is really important. And at the same time, one of the biggest discussions that has been had in the international community, I mean, this is a little bitty grain of sand, but it tells you what kind of is evolved. Everywhere else in the world, we are now sitting on the first floor. This is the first floor in the rest of the world. In the United States, we're on the second floor. Well, think about that in terms of data and location in a standard data structure. So that's what that data dictionary, that's where it comes into play, is the identifying and filtering, if you will, things like that.
This is equal to that.
It also involves the W3Cs involved with Building Smart. The OGC was a very big part of it, so that's all the spatial data as well. And now with the infrastructure, it doesn't go, it's not just the building of the facility, it's the whole site, and those will be ultimately connected. That'll hopefully be in the same data format. Whether it remains BIFC or not, I don't know, but right now that's the only thing I see on the horizon for all of us to work towards and work together on. So
other than the mandates that the other governments are doing, what is the strategy in the US here to sort of take the use of IFC forward? And like, playing the devil's advocate for a second, like, what motivation do the big software vendors have to adopt IFC?
right now, I don't see a big motivation personally for the big software vendors, and I think that's why they've got a decent market share and haven't had to. Now, that's not to say that they aren't malleable enough to do that at some point. I don't think the building owners have been educated enough yet to understand the value that'll be able to be added by the architectural community, the design community. I think the design community is still really caught up in producing drawings as their product of business. Drawings are not a product of business. They are a communication device. And that's why one of my first slides was how it works today, and we're shifting, and we think it's electronic because we're shifting, you know, email and PDFs over to somebody else, or we're sharing a data store somewhere that's a bunch of PDF that are just views of some iteration of the model. Even if you're using 3D software right now, it's still just a view of that model at some slice at some point in time, and who knows what the heck's changed since then. You know, I mean, nobody does. That's the difference of going to a data store that has the disciplines in place for the information traffic control, and the ability for everybody to access it and see, oh, there's an RFP right now for this.
Does IFC have versioning built into the data structure?
Versioning of the,
Well, if you think of it in terms of traditional hierarchical databases, relational databases, these days in enterprise databases, they support versioning so that you can actually
Yes.
revert, you can look back at what did it look
Yes.
like on
Well,
January 1st?
well, where that is being managed is, IFC is kind of like the, whether we're using English or Spanish. The versioning itself is handled through usually the, like BIM server and some of these other tools, the BIM collaboration format. They all retain all that chain of history,
Okay.
but it's all in IFC. Am I making any sense, Malcolm?
Sure, yeah.
So, what you look at, and then you can maybe drill down into prior versions and say, oh, there were 7 other versions of this particular object.
Right.
Or this object came in with RFP 871-920,
So I think, that's, to me, that's really the key of making this, valuable both in large construction companies and in institutions and such, being able to manage the.
And I'm not gonna say I'm not gonna say it's all figured out. I think that we're well along the roads, especially in the last couple of years. The BIM collaboration format's out on GitHub. I don't know if any of you are familiar with GitHub. You can get it out there. I'm on the chain. I get, who knows how many, I got a bunch of them yesterday where somebody came up with something. Actually, the guy that wrote Constructivity is real big on that particular one. Tim Chipman's his name. And he's part of the International Users Group. Point of interest, the Building Smart International originally was called the International Alliance for Interoperability. It changed about 10 years ago, but it was started by Autodesk.
That's what I heard.
Yeah, it was started by Autodesk and HOK, I believe. I don't know, HOK is still part of it. But and then that was in the 90s, and they started getting together because of needing this homogenized commonality of ways with, and again, it can be accessed by any kind of proprietary software anybody wants to write. That's not an issue. It's just the data store in the back end. How do we organize it so everybody, it can become an ecosystem of its own. That's really what it's all about, and a maintainable one. Yeah, it's amazing. I was part of the International Housing Alliance, which is NAHB is part of, and I attended a lot of those meetings, and we would have people from all over the world, and to hear their discussions or have it come up. Actually, Jean Sjogren is from the Norwegian Home Builders Association, but he's also at Building Smart. He was the secretary of Building Smart International for a while, and they're really able to get a more attentive audience in the past. I think we're really picking it up here in the U.S. now and starting to understand. I think the building product manufacturers at some point are going to see and start insisting, once it starts to get more knowledgeable here, that, for instance, Damon and I met with another company that one of my selfish goals of getting the resolution passed with National Association of Home Builders to recognize the National BIM standard, which included IFC, was so we could start getting some common file formats for. One of the barriers to utilization, I think, of true building information modeling, as it was defined here, has been the content. Architects, they resort to what they can find on the web. And 20 years ago, I worked in an architectural firm. We resorted to what we could find in the suites catalogs. That's where we came up with all of our information. So if they can find a sink out on the web, whether it's manufactured by Kohler or American Standard or whatever, and a decent model that is a decent representation, they can drag it into their model. Well, that depends on what software they're using right now. And as we move forward, it'll be much more, I think, effective for I don't care what software they're going to be using in the future, but if the current name brands of software could just bring in that model that is an IFC data format that also has, and this answers your question about some of these pollution problems, it's going to have the attributes attached to it for the water flow for that faucet and, you know, every, you know, the weight of it so that they can run a structural analysis based on the amount of sinks and cabinets and doors and whatever on how big that beam needs to be in these columns. I mean, that it all builds, it's all on the same thing. So they start bringing that in. Anyway, that content gets populated. There'll be more and more of the products coming out of the design firms that will be able to use better through the whole life cycle of the building. That'll have more information capabilities than it does today. Because many times it might just be, I mean, it could just be a 3D object that one of their techs at the architect firm drew up some generic sink to drop into, a 3D sink to drop into a cabinet that has nothing but the, the mesh for that sink as a graphic representation. So then it comes across empty. So I think we're going to see tools that are going to make sure that not only are we going to get more of this content out there in that, but we're also going to see tools that are going to catch that as it goes across. Like we have Navisworks has done so well with the class detection. That's a tool. And we're going to start seeing other ones that are going to say, hey, wait a minute, this sink doesn't have a faucet specified for it or whatever. I mean, I'm just throwing out an example. But I think we're going to see a lot more tools that are going to be imposing information requirements on information that's being developed.
So I guess a lot of what I've been hearing specifically relating to this technology and a whole bunch of other things is a lot of, I guess, top-down specificity management. But I guess the more I learn about complex systems, the more it seems like the real power is not in doing a whole boat ton of upfront planning and pushing that information down, but also being able to get that information to trickle up and work both ways. How does IFC kind of handle that?
IFC can handle that through the model view definitions I talked about. Mm-hmm. So at some point, this is just Steve's editorial comment, I think we're going to see where we'll have an MVDs that'll be a design level MVD or concept level MVD. So that sink that I just talked about may only have the attributes that you actually bring into it. I'll tell you what I think we'll really see eventually. I think we'll really see web services or something similar to a web service that we're not actually bringing the content in, we're actually linking to the information store of that IFC data model of that vendor's production. And we don't have to go get it and bring it into our model. Because as soon as we do that, we've disconnected from the ecosystem that produced it. So I think we're going to start seeing ways, and that's what I've spoken about before, and again, we're off on Steve's goose chase.
I think it's impossible to design everything because the new technology
Right.
is coming one after another. For instance, like a picture, we model from the photos. We model from the photos from the past and things like that. Then information we need to link is a collection of photos, and then the IFC itself is not really interested in the data from there at all. We just need the origin, the source. So I think if you try to cover everything, it's an important point. And then also data, in the past, our goal was creating a building model, but it's shifting, it's just a part of it. We will probably accumulate this for over the times, and the time becomes critical to design as well.
Mm-hmm.
So if you start thinking about it, then one data definition is just a part of the data.
But I think it does, there are parallels to the processes we've been using, especially at least here in the States, for the last 50 years. And that is in the design process, it starts out on scratch paper maybe, and even in an architect's office, the ones that I've worked in anyway, we had once, I worked as a CAD drafter while in AutoCAD in the 90s. So we would take those scratches and we would convert them into drawings, or CAD drawings, if you will. But then at the same time or simultaneously, another iteration was happening with the specification writers. They were further fleshing out this design, and the architect really wasn't involved in that at all. And then it even went a step further. Beyond that, once the architect office was done with it, it went out to the mechanical engineer, and he added more information. This is where the MVDs, I think we're gonna see start playing a role in, so that everybody is understanding what they're getting at what point. And they're only getting what they really need.
Yeah. Well, and being able to push that back up
Yeah.
and say, hey, you know, I needed this piece of information, you didn't give it to me, you know, and so on and so forth up the food chain. And I think that really makes sense as it carries all the way down to the contractor.
Yeah, absolutely.
where-
Oh, well, the installer, what should happen, I mean, we've talked about this, again here, the HVAC guy's here, and he's getting ready to hang the units, the air handler units. He scans it with his tool device that actually goes into the facilities manager thing, and they know the serial number, and now they know the date it was installed and who the tech was that installed it, from what company that installed it, and it starts its service life in the warranty, and then it also kicks off and starts the filter replacement that needs to happen in 3 months, or so many million cubic feet of air passing through that unit, or whatever it is.
Yeah.
It's a holistic ecosystem, I think, that we're talking about, that, and if any of us can come up with a better than IFC, I'll be all for it.
Lately, after I started working for Beam, this chat collaboration, like action items, who upgraded this, who changed this. We keep track of all of this.
Mm-hmm.
And then I just started to look through the information, and those are the information we didn't think about it before. And I started to hear the voices that that's a really cool feature, like keeping all the track, the changes and things. And I said, oh my God, the data just explodes. I have no idea when it stopped. It just, didn't.
No, but I think it's important not to look at it holistically, not only from the perspective that it's there, but try to look at it based on a
what
tool
each
set, a
person's
need,
needs.
or a function. What am I trying to accomplish? What day do I need to accomplish my job? Which hopefully my job is not about shuffling data around. It's about, replacing that filter in that air handler, or whatever. Maybe installing whatever. We don't need tape measures out on the sites anymore. If we had augmented reality headsets that the construction personnel were wearing, so I guess it's doing my home.
I got a question for you.
Yes, sir.
I work for an electrical contractor.
Yeah.
So I hear a lot of design on that portion. We do BIM quotations for a lot of layout. How would the IFC correlate in with like a Trimble or a Total Station or a TopCon for the field engineers out in the field actually doing the layout, not the design? I mean, would there be any benefit to it, or?
And I'm extremely familiar with TopCon, and I worked with the guy for a long time, and he used Total Station. He actually used Bangits, and we did a couple of time studies on the savings there. But no, that wasn't really using IFC. I'm sorry, I can't remember back exactly what we were using, but I don't even know if really IFC was that heavily utilized. But what IFC would hold, the information it would hold, potentially is, if that model had been developed or had gone through iterations of some new mean software that we don't even know of yet it's stored it in IFC, and the Total Station could read IFC, and all the geometry, all the coordinates, the locations are all within the IFC property sets.
Okay.
It's kind of a long thing, but if you look at it, that's some of the data that is in, and we're also in IFC 4 now, version 4. It's very important. We just went from 2x3, and ISO just last year approved version 4. But these property sets and the standards bodies, they take these kinds of challenges from people not unlike us and build them into the, I mean, any of us could submit a ballot for the next standard that's gonna come out and saying, hey, we need to know this information, and it'll go through the whole thing and get included. So that, and that's how a lot of it has evolved, in all honesty.
I just know a lot of, like, we use Trimble work for our company. I just know a lot of it's all inbox, there's no open source, you know, it's gotta be.
Well, but Trimble is one of the godfathers of a lot of this, IFC.
Really?
Yeah, in Europe. All their, and Tekla now is
Yeah.
part of that, you know, I mean, yeah, they still have, there's a great example. The Tekla is a black box, but it can interact with IFC.
That's good to know.
Yeah, yeah, it's used heavily, especially now with their concrete and their steel and all those programs. And that gets into even your area, Damon, with the fabrication.
Yeah, that's what we do, a lot of fabrication as well.
Yeah, and even the G codes and so forth. I was working with the steel folks on some of that and how to utilize it in IFC for fabrication codes.
Cool. Well, thank you, Steve.
Sure. Thank you. Hey.